All right, we had stopped looking at 2C worksheet after the first 4 problems, so we're going to pick up at number 5. And we have a spider on a web diagonally from one corner to the next. And so we want to know if each of those edges of the cube is 1.5. Let's deal with decimals so that it's easier to put in the calculator. If all the sides are 1.5, how long is that diagonal three-dimensionally through the middle? Now, one thing that we probably need to go ahead and figure out is that we're talking about this triangle right here. Now that is a right angle there, because it's, one edge of this goes vertically, one edge of this goes horizontally, but there's that diagonal through the middle that we don't know. We do know that this is 1.5. We don't know how long that is. And so we actually need to set up a separate triangle that blue triangle is going to be 1.5 here and 1.5 here. And so in our first attempt, we're doing 1.5 squared plus 1.5 squared equals, we'll call it A. And so if we say A squared, well, I'm going to get somebody confused with letters. So we're going to call this C. So we're going to say 1.5 squared plus 1.5 squared equals C squared, which is 2.25 plus 2.25, which is 4.5 equals C squared. So when I take the square root of both sides, well, actually, I'm going to leave it as the square root of 4.5, and you're going to see why in just a minute. There is method to my madness. Because you got to ask the question, where is this answer going? And this answer is going here. Because what are we going to turn around and do with the red triangle? The red triangle has got 1.5 going up the side. It's got the square root of 4.5 going this way, and we are going to find the distance that the spider is crawling through the middle. So we're going to say 1.5 squared plus square root of 4.5 squared. Oh, is that a thing of beauty or what? Because these guys are going to cancel each other out, and we're just going to have 4.5 left over. And you thought that was going to be ugly. All right, 6.75 is equal to D squared. So D is going to equal the square root of 6.75, which, checking with my handy and dandy calculator, square root 6.75, enter. 2.598, you might as well call it 2.6. And they said that those are feet. So this would be about 2.6 feet. And we'll do that. I love those cube problems like this because you have to, first of all, take the two sides and figure out the diagonal along one edge, one side of the thing, and then create this third triangle that involves that diagonal through the base. And one of your sides is now diagonal through the cube. It's probably easier to take a box and try and imagine from one corner to the next, and that, having a sense in real space of what you're dealing with probably does help. All right, write a piecewise function which models this graph. So Let's see now, we'll start with our usual function language. I see two pieces of it, so we are expecting two colors. This guy is going up from here, and he crosses here, and he crosses here. Now here, I'm going rise of 1, 2, 3, and a run of -2. So you could say either, well, does it matter? I guess I need to ask the question, is this the same as that? No, they're both a fraction with a negative value, aren't they? Most of the time, we're used to seeing the negative on the top. Now, does that mean I could go down 3 and over 2? Yes. So I'm going to say -3 over 2x, and it crosses where y is -4. So it's going to look like that. And it is for all x's that drop below 0. And then we're going to do the guy in black, that he is up 1 over 1, up 2 over 4. He didn't stretch or flip or anything like that. All they did was they moved him down 1, which means I'm going to say square root of x minus 1. He got moved down 1. And this is, there's a solid there, so it is everything greater than or equal to 0. And that should take care of that one. All right, we've got to graph this beast and then ask the question, is it continuous? Okay, so we'll start with the first one. Square root of x plus 2. That means we are moving not to the right, but to the left. And we are going to go up 1 over 1, up 2 over 1, 2, 3, 4, up 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, so if our graph is going to go like that, we're saying that when x is less than 2, that's 2 right there. So it's going to do that. It's going to have a solid dot at the end, is this less than or equal to, but that is as far as it's going. So we're good with that one. Then, for this one, we're going where y is 2, which y is 2 right there. And we're going open circle from where x is 2 to an open circle where x is 4. And so that's what that should look like. Now, x minus 4, that is to say 1x minus 4. I'm going to start from -1, 2, 3, 4. I'm going to start from down here. 1x minus 4 means a slope of 1, up 1 over 1, up 1 over 1, up 1 over 1, and so on. But we don't pick up until we get to 4. X is 4 there. And we're still doing up 1 over 1, up 1 over 1, and so we're going to go off in that direction. And we can erase these guys. Now, is the function continuous? We can look at the graph and realize that there is a problem right here. And we can check out, in 4, in this particular case, you're going to have 4 and 2. Anything here is always going to have a y of 2. But here, when you stick a 4 in, 4 minus 4 is 0. So you definitely know that this is not continuous. And I believe that was it. Yes.